Caching Architecture Introduction. Caching architecture is the design of where, when, and how to store frequently used data temporarily, so applications can respond faster and reduce load on backend systems. Software engineers use caching for: check. Faster API responses, reduced database load, better scalability, lower latency, high traffic applications, product catalogs, user sessions, authentication tokens, search results, configuration data, CDN content, microservices optimization. A common learning topic is: how can software engineers design caching architecture correctly? This guide explains caching basics, cache layers, cache aside pattern, read through cache, write through cache, write behind cache, refresh ahead cache, Redis caching, CDN caching, browser caching, local cache, distributed cache, cache invalidation, cache consistency, cache stampede, TTL, eviction policies, Spring Boot. Caching, real-world architecture, common mistakes, interview questions. Simple definition: caching means storing frequently accessed data in a faster place so future requests are quicker. Simple flow: client requests product details. Check cache. If found, return from cache. If not found, read database. Store result in cache, return response. Simple idea: cache equals fast temporary storage. Database equals permanent source of truth. Why caching matters. Without cache, every request hits database. Database becomes slow. API latency increases. System scales poorly. With cache, frequent requests served from cache. Database load reduced. Response time improves. System handles more traffic. Benefits: lower latency, better throughput, lower database load, improved user experience, cost reduction, better scalability, faster reads, protection from traffic spikes. Real-world caching examples: product catalog get/API products 1001 /Redis cache. Database if cache miss. Used because product data is read frequently and changes less often. User session ID Redis user session data. Used for scalable login sessions across multiple servers. CDN cache user. ZDN edge location. Image, CSS, JS, video. Used for static files close to users. API response cache get/API categories. Cache response for 10 minutes. Used for data that does not change often. Configuration cache. Application startup. Load config from database. Store in memory cache. Used to avoid repeated DB calls for settings. Caching architecture overview: client, browser cache, CDN cache, API gateway cache, application local cache, distributed cache, Redis, database. Each layer has a purpose. Layer purpose: browser cache, cache static assets on user browser. CDN cache, cache static public content near users. API gateway cache, cache API responses. Local cache, fast in-memory app cache. Distributed cache, shared cache across services. Database, source of truth. Important caching rule: cache should improve performance, but database should remain the source of truth. Do not treat cache as permanent storage unless the system is specifically designed that way. Core caching concepts. Concept meaning: cache hit, data found in cache. Cache miss, data not found in cache. TTL, time to live. Eviction, removing old cache entries. Invalidation, removing stale cache data. Cache key, unique identifier for cache data. Cache value, stored cache data. Local cache, cache inside one application instance. Distributed cache, shared cache like Redis. Stale data, old data returned from cache. Warm cache, cache already has useful data. Cold cache, cache is empty. Step 1, cache hit. Cache hit means requested data exists in cache. Example: request product ID equals 1001. Redis has product 1001. Return immediately. Benefit: fast response, no database call, lower system load. Step 2. Cache miss. Cache miss means requested data does not exist in cache. Example: request product ID equals 1001. 1. Redis does not have product 1001. 2. Read from database. Store in Redis. Return response. Cache miss is slower than cache hit, but after first request, future requests become faster. Step 3. Cache key design. Cache key is very important. Good key examples: product 1001, user 501, category list, order 1001, summary, search iPhone, page 1, size 20. Bad keys: data product user list temp. Good cache key should include entity name, unique ID, query filter parameters, version if needed, tenant if multi-tenant, language currency if response changes. Example multi-tenant key: tenant ABC, product 1001. Example API cache key: products, category, electronics, page 1, size 20, sort, price desk. Step 4. TTL, time to live. TTL means how long cache entries stays valid. Example: cache product for 10 minutes, cache category list for 1 hour, cache off session for 30 minutes. TTL examples: data suggested TTL, product details 5 to 30 minutes, category list 1 to 24 hours, user profile 5 to 15 minutes, search results 1 to 10 minutes, session data 15 to 60 minutes, feature flags 1 to 5 minutes, static assets days, months with versioning. Important: short TTL equals fresher data, less cache benefit. Long TTL equals faster reads, higher stale data risk. Step 5. Cache eviction. Eviction means cache removes entries to free memory. Common eviction policies. Policy, meaning LRU, least recently used removed first. LFU, least frequently used removed first. FIFO, oldest item removed first. TTL-based, expired items removed. Random item removed. Use case: cache memory is full. Eviction policy decides what to remove. Step 6. Cache aside pattern. Cache aside is the most common pattern. Application controls cache. Read flow. Application receives request. Check cache. If hit, return data. If miss, query database. Put result in cache. Return data. Java, Spring Boot, pseudocode. Public product response get product, long product ID. String key equals product plus product ID. Product response cached equals Redis template.ops for value.get key. If cached is null, return cached. Product equals product repository dot find by id product ID, or else throw new runtime exception product not found. Product response equals to response product. Redis template dot ops for value set key response duration of minutes 10. Return response. Use cache aside for common backend systems: user profile, category data, read heavy data, common backend systems. Step 7. Cache aside update flow. When data changes, update database, delete cache entry, next read reloads cache. Example: transactional, public product response, update product, long product ID, update product request. Product equals product repository, find by ID product ID, or else throw new runtime exception, product not found. Product.setName, request.name. Product.setPrice, request.price. Product saved equals product repository dot save product. Redis template dot delete product add ID. Return to response saved. Why delete instead of update cache? Deleting cache is usually simpler and safer. Next read repopulates cache from database. Step 8. Read through cache. Read through means application asks cache, and cache automatically loads from database if missing. Flow. Application, cache, if miss, database. Benefit. All API code is simpler, all cache loading is centralized. Drawback. Cache system needs loader logic. Less flexible. Not always supported directly. Step 9. Write-through cache. Write-through means write-through. Writes go to cache and database together. Flow. Application writes data. Data cache updated. Database updated synchronously. Benefits. Cache stays updated. Fewer stale reads. Drawbacks. Write latency increases, database still hit on every write. Write failure handling is more complex. Use for. Caps CADA that must stay cache consistent. Caps read-heavy systems with controlled writes. Step 10. Write behind cache. Write behind means application writes to cache first. Database is updated later, asynchronously. Flow. Application writes to cache. Return response. Background process writes to database. Benefits. Very fast writes. Reduced database pressure. Batch database writes possible. Drawbacks. XX risk of data loss if cache fails. Harder consistency. X complex failure handling. X not good for critical financial data. Use carefully for analytics, counters, non-critical data, high-value writes. Avoid for payments, bank balances, critical orders, legal, audit data. Step 11. Refresh ahead cache. Refresh ahead means refresh cache before it expires. Flow. Cache entry close to expiry. Background refresh starts. New value loaded. Users continue getting fast responses. Use for high traffic data, predictable hotkeys, product catalog, configuration data. Benefit. Avoids sudden cache miss spikes. Improves response stability. Step 12. Local cache. Local cache is stored inside application memory. Example: Spring Boot Instance 1, memory cache. Spring Boot Instance 2, memory cache. Spring Boot Instance 3, memory cache. Tools. Caffeine, Guava Cache, Concurrent Hash Map, Spring Cache Abstraction. Benefits. Extremely fast. No network call. Simple. Drawbacks. Dash. Each instance has separate cache. Stale data across instances. Memory limited. Cache lost on restart. Use local cache for click configuration, feature flags, small reference data, rarely changing data. Step 13. Distributed cache. Distributed cache is shared by multiple application instances. Example: Spring Boot Instance 1, Spring Boot Instance 2, Spring Boot Instance 3, Redis cluster. Tools. Tools. Redis, Memcached, Hazelcast, Apache Ignite. Benefits. Shared across instances, scalable, good for sessions, good for shared API cache, survives app restart. Drawbacks. XX network latency, XX extra infrastructure, XX serialization needed, XX cache outage handling required. Step 14. Local cache versus distributed cache. Feature local cache, distributed cache. Speed, very fast, fast but network call. Shared, no, yes. Storage, app memory, external system. Consistency, harder, better shared consistency. Example: Caffeine, Redis. Best for small reference data. Shared data session API cache. Simple rule. Use local cache for very fast small data. Use distributed cache when multiple instances need shared cache. Step 15. Two-level cache. Two-level cache uses both local and distributed cache. Flow. Application, dash, local cache, dash, if miss, Redis cache, dash, if miss, database. Benefits. Yes, fastest reads from local cache. Shared fallback through Redis. Reduced Redis load, reduced database load. Drawback. X. More complex invalidation. Stale data risk. harder debugging. Use 4. Capital, very high traffic read-heavy systems. Capital, product catalog, configuration service. Capital, pricing data with careful invalidation. Step 16. Redis caching architecture. Redis is commonly used as distributed cache architecture. Client, Spring Boot API, Redis cache, PostgreSQL database. Use Redis 4. Check API response cache. Check session store. Rate limiting. Check distributed locks. Check counters. Check leaderboard. Check feature config cache. Check token blacklist. Common Redis key examples. Product 1001. User session ABC123. Rate limit user 501. Category list V1. Order summary 9001. Step 17. Spring Boot cache abstraction. Spring Boot supports annotation-based caching. Enable caching. Configuration. At enable caching. Public class cache config. Cache method. At cacheable value equals products. Key equals number sign product ID. Public product response get product. Long product ID. Product equals product repository dot find by I dot product ID. Or else throw. New runtime exception. Product not found. Return to response product. Meaning. First call executes method and stores result. Next call with same product ID returns from cache. Step 18. Cache evict in Spring Boot. When updating data, remove cache. At cache evict value equals products, key equals pound product ID. Public product response update product. Long product ID. Update product request. Product equals product repository find by id product ID. Or else throw new runtime exception. Product not found. Product.setName request.name. Product.setPrice request.price. Product saved equals product repository.save product. Return to response saved. Simple idea. Update DB. Remove cache. Reload on next read. Step 19. Cache put in Spring Boot. At cache put updates cache with method result. At cache put value equals products, key equals hash product ID, public product response update product and cache, long product ID update product request. Product equals product repository find by ID product ID dot or else throw new runtime exception product not found. Product.setName request.name. Product.setPrice request.price. Product saved equals product repository.save product. Return to response saved. Use when you want cache updated immediately. Returned value is the new correct value. Step 20. CDN cache. CDN means Content Delivery Network. CDN caches content near users. Architecture. User in Canada. Nearby CDN edge. Origin server if cache miss. Used for images, videos, CSS, JavaScript, static HTML, public API responses sometimes. Benefits. Faster global delivery, lower origin traffic, better availability, protection from traffic spikes. Examples: CloudFront, Cloudflare, Akamai, and Fastly. Step 21. Browser cache. Browser cache stores assets on user device. Example headers. Cache control, max age 3153600, etag ABC123. Good for CSS, JS bundles, images, fonts, static files. Important. Use versioned file names for long browser caching. Example: app 8fd92.js style.a7d91.css. When file changes, file name changes. Step 22. HTTP cache headers. Common headers. Header purpose. Cache control. Defines caching rules. etag, validation token, last modified, last update timestamp, expires, expiry time, vary, cache based on request header. Example: cache control, public, Max age equals 3,600. Meaning, can be cached publicly for 1 hour. Private data. Cache control. Private, no store. Use for. Check user-specific pages, sensitive responses, banking, payment pages. Step 23. API Gateway Cache. API Gateway Cache stores API responses near gateway layer. Architecture. Client dash API Gateway Cache dash backend service database. Good for CAC public read APIs, product listing, category list, reference data, configuration APIs. Be careful with no user-specific data, no auth-sensitive data, no rapidly changing data, no personalized responses. Step 24. Database Query Cache. Some systems cache query results. Example. Select all from products where category ID equals 10. Cache key. Query products category 10, page 1. Useful for R. Expensive queries, reporting, search filters, dashboards. Risk. Negative. Invalidation complexity. Negative. Stale query results. Negative. Many parameter combinations. Negative. Large memory usage. Step 25. Cache invalidation. Cache invalidation means removing or updating cache when data changes. Common strategies. TTL-based expiration. Delete cache on write. Update cache on write. Event-based invalidation. Versioned cache keys. Manual cache clear. Refresh ahead. Most common. Update DB. Delete cache. Reload on next read. Hard part. Knowing all cache keys affected by one data change. Example. Product price changes. Need to invalidate. Product 1001. Category electronics. Page 1. Search keyboard. Page 1. Homepage. Featured products. Step 26. Event-based cache invalidation. Use Kafka, RabbitMQ events to invalidate cache across services. Flow. Product service updates product. Publishes product updated event. Catalog cache service consumes event. Deletes affected cache keys. Example event. Event type, product updated. Product ID, 1001. Category ID, 10. Updated at 2026-06-10 T 12000Z. Use for microservices, distributed caches, multiple services caching same data, read models, search indexes. Step 27. Versioned cache keys. Instead of deleting many keys, use version in key. Example. Product V1 1001. Category V1 electronics. When data model changes. Product V2 1001. Category V2 electronics. Old keys expire naturally. Good for deployment changes, schema changes, response format changes, static assets. Step 28. Cache stampede. Cache stampede happens when many requests miss cache at same time. Example. Hotkey expires, 10,000 requests arrive. All hit database. Database overload. Solutions. Locking, request coalescing. Jittered TTL. Refresh ahead. Stale while revalidate. Pre-warming cache. Step 29. Cache penetration. Cache penetration happens when requests are made for data that does not exist. Example. Request product ID equals 9999999. Cache miss. Database miss. Repeated many times. Solutions. Cache. Null results briefly. Validate input. Bloom filter. Rate limiting. Block abusive requests. Example. Cache product not found for 1 minute. Step 30. Cache avalanche. Cache avalanche happens when many cache keys expire at the same time. Example. Thousands of keys expire at 10 a.m. Database suddenly receives huge traffic. Solutions. Check. Randomized TTL. Check. Stagger expiration. Check. Pre-warm cache. Check. Refresh ahead. Check. Rate limiting. Check. Fallback responses. Example jitter. TTL equals 10 minutes plus random 0 to 2 minutes. Step 31. Stale data. Stale data means cache returns old data. Example. Product price changed to $99. Cache still returns $89. How to reduce stale data. Shorter TTL. Cache eviction on update. Event-based invalidation. Read after write consistency. Versioned keys. Avoid caching critical mutable data. Important. Some stale data is acceptable in many systems. Some stale data is unacceptable in payment, banking, inventory systems. Step 32. Caching and consistency. Caching creates consistency trade-offs. Strong consistency. Always show latest data. Eventual consistency. Data may be old briefly, but eventually becomes correct. Use strong consistency for C. Account balance. C. Payment status. C. Inventory during checkout. C. Security permissions. Use eventual consistency for X. Product catalog. X. Recommendations. X. Category list. Analytics. X. Search results. X. Feed counts. Step 33. What not to cache. Avoid caching. Highly sensitive data without strong controls. Rapidly changing critical data. One-time tokens. Passwords. Raw access tokens. Private personal data unnecessarily. Payment authorization details. Data requiring immediate consistency. Be careful caching. User profile. Permissions. Inventory. Pricing. Cart. Financial data. Rule. Cache only when you understand freshness, security, and invalidation requirements. Step 34. Caching user-specific data. User-specific cache key must include user ID. Bad. Dashboard. Summary. Better. User 501. Dashboard. Summary. Also include tenant when needed. Tenant ABC. User FI01. Dashboard. Summary. For authenticated, private data. Use. Private cache. Use. Avoid CDN public caching. Use. Validate authorization. Use. Avoid leaking one user's data to another. Step 35. Caching in microservices. Microservices may cache data from other services. Example. Order service caches product summary from product service. Risk. Product changes, but order service cache is stale. Solutions. Short TTL, product updated events, cache versioning, direct call for critical path, separate read model. Architecture. Product service, product updated event Kafka. Order service invalidates product cache. Step 36. Caching with Redis in Spring Boot. Dependency. Dependency, Group ID, Org Spring Framework Boot. Group ID, Spring Boot Starter Data Redis. Artifact ID. Config. Spring, Data, Redis, Host, Localhost, Port 6379. Simple Redis usage. @service, public class, product cache service. Private final Redis template. String, product response. Redis template. Public product cache service. Redis template string, product response. Redis template. This Redis template equals Redis template. Public product response. Get string key. Return Redis template. Ops for value get key. Public void put string key product response value. Redis template dot ops for value. Set key value. Duration of Minix 10. Public void delete string key. Redis template delete key. Step 37. Caching architecture for product API. Flow. Get/API product/ID. Spring Boot controller product service. Redis cache lookup. Hit return product. Miss query PostgreSQL. Store in Redis. Return product. Controller. @REST controller. @request mapping. API products. Public class product controller. Private final product service. Product service. Public product controller. Product service. Product service. This product service equals product service. @get mapping. @ID. Public product response, get product, at path variable long ID, return product service, get product, ID, service, at service, public class, product service, private final, private final product cache service, public product service, product repository, product cache service. This dot product repository equals product repository. This dot cache service equals cache service. Public product response, get product, long ID. String key equals product plus ID. Product response cached equals cache service dot get key. If cached equals null, return cached. Product equals product repository dot find by ID dot or else throw. New runtime exception, product not found. Product response equals to response product. Cache service dot put key response. Return response. Private product response to response, product. Return new product response. Product get ID, product get name, product get price. -3. Cache metrics. Monitor cache performance. Important metrics. Cache hit rate, cache miss rate, eviction count, memory usage, Redis latency, Redis CPU, Redis connections, cache key count, database load after cache miss, hotkeys, cache hit rate, cache hits, total cache requests. Example, 90 cache hits, 10 cache misses, hit rate equals 90%. Good cache should improve. Response time, database, CPU, API throughput, user experience. Step 39, cache monitoring dashboard. Dashboard sections. Cache health dashboard. 1. Cache hit rate. 2. Cache miss rate. 3. Redis latency. 4. Redis memory usage. 5. Evicted keys. 6. Hotkeys. 7. Database query rate. 8. API response time. 9. Error rate. 10. Cache connection errors. Alert examples. Cache hit rate drops below 60%. Redis memory usage above 85%. Redis unavailable. Eviction count spikes. Database traffic spikes after cache miss storm. Step 40. Real-world architecture. E-commerce caching architecture. User down. Browser cache down. CDN down. API gateway down. Spring Boot product API down. Redis cache down. Cached data. Product details. Category list. Product images through CDN. Homepage recommendations. Search filters. Feature flags. User session. Not cached or carefully cached. Check payment data. Checkout inventory. Order final status. Security permissions. Step 41. Caching decision checklist. Before caching, ask 1. Is this data read frequently? 2. Is it expensive to compute or query? 3. Can stale data be tolerated? 4. How often does it change? 5. How will cache be invalidated? 6. What is the TTL? 7. What is the cache key? 8. Is the data user specific? 9. Is the data sensitive? 10. What happens if cache is down? If you cannot answer these, do not cache yet. Common beginner mistakes. 1. Caching everything. Bad. Cache every API response. Better. Cache only data that benefits from caching and has clear invalidation rules. 2. No cache invalidation plan. Bad. Put data in cache and forget it. Better. Define TTL and invalidation strategy before caching. 3. Using same cache key for different users. Bad. Dashboard. Summary. Problem. User A may see user B data. Better. User 501. Dashboard. Summary 4. Caching sensitive data carelessly. Bad. Cache private data in public CDN. Better. Use private no-store headers and secure backend cache. Long TTL for frequently changing data. Bad. Cache inventory count for 1 hour. Better. Use short TTL or avoid caching critical inventory state. 6. No monitoring. Bad. Cache exists, but nobody monitors hit rate or failures. Better. Monitor hit rate, miss rate, latency, memory, and database impact. 7. No fallback when cache fails. Bad. Redis down equals entire API down. Better. Fallback to database for non-critical cache failures when possible. Best practices. Cache read-heavy data. Define cache key clearly. Use TTL. Invalidate on writes. Monitor cache hit rate. Avoid caching sensitive data publicly. Use Redis for shared cache. Use local cache for small reference data. Use CDN for static assets. Use browser cache for version static files. Add TTL jitter for hot keys. Prevent cache stampede. Cache nulls briefly for missing data. Design idempotent cache refresh logic. Treat database as source of truth. Document cached entities and invalidation rules. Test cache failure scenarios. Caching interview questions. 1. What is caching? Caching is storing frequently used data in a faster temporary storage layer to reduce latency and backend load. 2. What is cache hit? Cache hit means requested data is found in cache. 3. What is cache miss? Cache miss means requested data is not found in cache, so the system must fetch it from source like database. 4. What is TTL? TTL means time to live. It defines how long cache data remains valid. 5. What is cache aside pattern? Cache aside means application checks cache first, reads database on miss, stores result in cache, and returns data. 6. What is write through cache? Write through cache writes data to cache and database together synchronously. 7. What is write behind cache? Write behind writes data to cache first and updates database asynchronously later. 8. What is cache invalidation? Cache invalidation means removing or updating stale cache data when source data changes. 9. What is cache stampede? Cache stampede happens when a hot cache key expires and many requests hit the database at the same time. 10. How do you prevent cache stampede? Use locking, request coalescing, TTL jitter, refresh ahead, stale while revalidate, or cache pre-warming. 11. What is cache penetration? Cache penetration happens when repeated requests query non-existing data, causing cache misses and database hits. 12. How do you prevent cache penetration? Cache null values briefly. Validate input, use Bloom filters, and rate limit abusive requests. 13. What is cache avalanche? Cache avalanche happens when many cache keys expire at the same time and database receives sudden huge traffic. 14. Local cache versus distributed cache. Local cache is inside application memory and very fast, but not shared. Distributed cache, like Redis, is shared across instances, but requires network calls. 15. Redis versus database. Redis is fast, temporary in-memory storage. Database is persistent source of truth. 16. What should not be cached? Avoid caching passwords, raw tokens, sensitive private data, critical rapidly changing data, and data requiring immediate consistency. 17. What is stale data? Stale data is old data returned from cache after source data has changed. 18. How do you cache user-specific data safely? Include user ID and tenant ID in cache key, and avoid public caching for private data. 19. How do you monitor cache? Monitor hit rate, miss rate, latency, memory usage, eviction count, error rate, and database load. 20. What is the most common caching pattern? Cache aside is one of the most common patterns in backend systems. Caching roadmap, beginner level. Learn. Cache hit, cache miss, cache TTL, cache key, cache aside, local cache, Redis basics. Build. Spring Boot product cache using Redis, intermediate level. Learn. Cache, invalidation, distributed cache, write through, write behind, CDN, browser cache, Spring cache annotations. Build. E-commerce product and category caching system, advanced level. Learn. Cache stampede, cache penetration, cache avalanche, cache two-level cache, event-based invalidation, cache monitoring. Build. Cloud-native caching architecture with Redis, CDN, and Kafka invalidation, 30-day learning plan. Week 1, caching basics. Learn. Cache hit, cache miss, TTL, eviction, cache key design, cache aside pattern. Practice. Implement in-memory cache with HashMap. Week 2, Redis and Spring Boot. Learn. Redis basics. Redis template. Spring cache. @cacheable. @cacheevict. @cacheput. Practice. Build Spring Boot product cache using Redis. Week 3, cache invalidation. Learn. CTL strategy. Delete on write. Event-based invalidation. Versioned keys. Stale data handling. Practice. Invalidate product cache when product is updated. Week 4, advanced architecture. Learn. CDN cache, browser cache, two-level cache, cache stampede, cache penetration, cache monitoring. Practice. Design full e-commerce caching architecture. Real-world project. Cloud-native product catalog cache. Architecture. React front-end. CDN for static files, images. API gateway. Spring Boot product API. Redis distributed cache. PostgreSQL. Kafka product updated events. Features. Cache product details. Cache category list. Cache search filters. Invalidate cache on product update. Use TTL. Use Redis. Use CDN for images. Use browser cache for static files. Monitor hit rate. Handle cache miss. Prevent cache stampede. Endpoints. Get API products/ID. Get API categories. Get API products category equals electronics. Page 1. Put API products/ID. Cache keys. Product 1001 category list products category electronics. Page 1 size 20. Invalidation event. Event type product updated. Product ID 1001. Category ID 10. Caching architecture is essential for scalable backend and cloud-native systems. Important concepts include cache hit, cache miss, TTL, eviction, cache key, cache aside, read through, write behind, refresh ahead, local cache, distributed cache, Redis, CDN, browser cache, invalidation, stale data, cache stampede, cache penetration, cache avalanche, monitoring. Software engineers should remember, caching improves performance, but it introduces consistency and invalidation challenges. Key idea: trace. Cache read heavy, expensive, and frequently accessed data only when you understand freshness, invalidation, security, and failure behavior.